this opener, we've actually been solving equations like this already, where when we see 2x divided by 9, we undo this fraction in 2 steps. We first undo the division by multiplying. So I'm going to multiply both sides by 9. And it's really important that we understand why we're multiplying by 9, right? It's to undo the dividing by 9. So what I've seen happen is a lot of students, they multiply by 9, but then they're multiplying the 2x by 9 as well. Well, we're not trying to multiply that 2x by anything, right? Our main objective here is to get rid of the division. So multiplying by 9 gets rid of that division. So we're still left with 2x, and it equals 4 times 9, which is 36. And then I can divide by 2 and get x equals 18. Okay, so that's essentially what we're going to work on today. It's just that now we're going to have fractions on 2 different sides. And we're going to undo the division the same way as to how we've been going about this. All right, so these problems are referred to as proportions. Proportions, just a fancy name for fractions. So when we have 2 fractions equal to each other or 2 proportions equal to each other, we're just going to undo the division twice. Okay, some of you have heard of cross multiplying before. That's essentially what this is. I'm not going to teach cross multiplying because I think with that we don't really think about the concept of what we're trying to accomplish. Okay, so I'll do these first 2 and then we'll find some on the back for you all to try. But I've got 6 divided by 5 equals m divided by 9. Now, I want to point out here that really think about our goal when we're solving is to get the variable by itself. Well, this can happen really easily with number 1 here by me just multiplying both sides by 9. Right? When I multiply by 9, okay, that gives me just an m. And then on the other side, when you're multiplying fractions, okay, and I'll grab calculators here, but I want to talk about how we do this as well. Anytime you multiply fractions, you multiply the 2 tops of the fractions together, so the numerators, and then the denominators together. So I can make 9 a fraction by making it 1. And so this is 9 times 6 in my numerator, which is 54, and then divided by 5. Okay, and again, we can have the calculator do that. So with each of these, I will kind of explain how to do the fraction piece. But I could go 6 divided by 5. And remember, anytime we're multiplying or working with a fraction, it needs to go in the parentheses like that. So 6 divided by 5 times 9, it's going to give it to me as a decimal. And let's just see if this is the same decimal that I got. So 54 divided by 5 is the same thing as 10.8. I am perfectly okay with you leaving your answers in this fraction form, or if you write it as a decimal, being 10.8. Okay, so either answer works. Decimal fraction doesn't matter. Yeah. The only thing that I always check the division. If it works out to be a whole number, then we're going to write that whole number. But if it doesn't divide out like we have here, then the fraction is perfect. No, I mean, if you know how to simplify, you can, but it's not something I'm going to make you do until we actually cover that. Okay? Good questions. All right. Well, let's look at number 3. Again, I'm noticing that my variable is in the top left. I can undo that fairly easily. Okay, work to get it by itself by first undoing the dividing by -3. I'm going to multiply both sides by -3. And again, it's important that we understand why we're doing this. We're doing it to get rid of the division. So that makes this left side just 2 absolute value of x. And the right side, I'm going to make -3 a fraction by putting it over 1 and multiplying the 2 tops of those fractions. -4 times -3 is a positive 12, and then divided by 7. Now, when we divide, because that's the last thing we need to do, get the absolute value by itself, I need to divide both sides by 2. Dividing by fractions is not as straightforward as multiplying. So this might be one that I say, let's just do the calculator. We might as well do it. So here's how we divide fractions. You're going to hear the phrase copy.flip. where the top fraction remains unchanged. So I copy that fraction down. I don't do anything to it. 12 over 7. So that's the copy. The dot means to change the division to multiplication. And then the flip means to flip the bottom part of the fraction, or what fraction we're dividing by. So if I were to flip 2, what does that turn into? What's like that reciprocal? You got it. Yeah, 1 over 2. Okay, so multiplying by 1 over 2, I get absolute value of x equals 12 times 1 is 12. 7 times 2 is 14. So 12/14. Again, the calculator can do that for us. 12 divided by 14. Okay, it's 0.857. And if you want to give the decimal answer, that's fine. Really, as you progress forward in math, leaving your answers exact, so like the fraction form is better. But in this class, I'm okay with either a rounded answer or the fraction form. The one thing that we need to always remember with absolute value is that we usually get 2 solutions. And so we need to say that x equals plus or minus 12/14, or x equals 0.857. Okay, if you want to write it as its decimal form. Okay, questions so far? And yeah, all the fraction work I'm doing by hand. I'll do another one where we do it all in the calculator. I think it's worth explaining, but I'm cool with y'all doing everything on the calculators too.
So how up there?
Yeah.
Is divided by 2, like under the 12 over 7.
Yeah, because that's when I.
But then how does it turn into times?
Yeah. All right, so Nico's asking, and this is coming into the dividing of fractions. So what we were working on is we had 12 divided by 7 and then divided by 2. So when you're dividing fractions, and this is not something I'm expecting you to get down right away. Okay, in fact, you do a lot of work with fractions when you get to Algebra 2, so that's a couple years for you all. But to do the division, if I have 12/7 divided by 2, to do the division, I take the top fraction, I leave it the same. We change the division to multiplication, and we multiply it by the reciprocal of that bottom fraction. Okay, so that's just how we divide the fractions. And again, I have no problem, like in your calculator, if you go 12 divided by 7 and then divide that by 2, well, look at that. I get the exact same answer that we had. Okay, so you can always do things with the calculators if the fraction work's a little confusing. All right, thanks for the questions. Why don't you all try number 4. Number 6 is going to be a little bit different. And I don't know that we're going to really skip any of these. We might work through all of these today. Yeah, but everyone try 4. It should be fairly similar to what we just worked on. And I'll do the same. But starting with getting the x squared by itself, I'm going to multiply both sides by 3. When I multiply the right side, again, multiplying fractions, it's the top numbers together. 9 times 3 is how I got 27. 4 times 1 is 4. Then we need to square root all that. Okay, so when you're square rooting, just remember that you're going to need parentheses around that fraction. So you'd go second square root, then open a parenthesis, and take 27 and divide it by 4. Wow, I got that wrong. What did I do the first time? I'm wondering, and this is why parentheses are so important, if I did this, 27 and then divided by 4, it's the same thing. I have no idea what I typed in. Let's fix that. 2.6. All right, so with all these, it's definitely going to take some practice with the calculators. And I'll keep showing you different ways of how it can work. So my suggestion, we are going to do most of these problems. Whenever you're seeing me do the calculator stuff, I would pick that calculator up and try to follow along and press the same buttons that I'm doing. That way we start to get a hang of it. All right, number 6. Notice 6 is set up a little bit different. And it's set up different in the sense that our variable is in our denominator. So this is actually going to be a case where it's going to make most sense to multiply both sides and get rid of both dividing. So let's start with this left side. I have 10 divided by 3. I'm going to undo the dividing by 3 by multiplying both sides by 3. So that gets rid of That 3 there. Then I have 10, and it equals on the right side. Again, I'm going to multiply the fractions. 7 times 3 is 21. The denominator, 5 absolute value of x times 1, just stays the same. So that's 5 absolute value of x. All right, now here's the part that's a little bit different. That right side. If I were to read that out loud, that says 21 divided by 5 absolute values of x. So we're going to undo the dividing by the 5 absolute value of x by multiplying both sides by 5 absolute values of x. So that gets rid of the division on the right side. Notice how the 21 is not changing, right? I'm multiplying to get rid of that division. And so I get 21. On the left side, 5 absolute value of x times 10 makes that 50 absolute values of x. And now we're really close. Okay, in fact, right, this looks a lot more familiar than what we've already been solving. Okay, once we get rid of all that division. So now I'm going to divide both sides by 50. So absolute value of x equals 21 over 50. Where 21 over 50 as a decimal. Okay, 0.42. It actually works out fairly nice. I guess that makes sense. Okay, so then our solutions, we're not done, so I still have absolute value of x, is that x needs to equal plus or minus 21 over 50 or plus or minus 0.42. Again, both values are perfectly okay with me there. Okay. Any questions there? All right. Now these next few are a little bit trickier. So I'm going to do 7 and 8, and I'll probably have you all do 9 and 10. But notice that we've got more things going on with our variable now. Okay, so again, reading this stuff out loud can be really helpful. I've got 11 divided by 3x plus 3. So the first thing I'm going to work to accomplish here is get rid of the dividing by 3x plus 3. So I'm going to multiply both sides by that 3x plus 3. Now here's the part that we need to think about. Okay, the whole reason why we're multiplying by 3x plus 3 is to get rid of the dividing by 3x plus 3. So the left side is just 11. But on the right side, this 3x plus 3 needs to multiply to this entire fraction. So maybe I put it over 1. That way I know that I'm still multiplying the numerators together and the denominators together. So I need to do 3 times the 3x plus 3, which has us distributing. So that's 9x plus 9, and it's still being divided by 11. Okay, so when we're multiplying by more than one term, it's more distribution. And now I have 9x plus 9 divided by 11. We want to get rid of the division, so I'm going to multiply both sides by 11. And so I get 121 equals 9x plus 9. Now this is just like an equation for what we've been working on. Only difference is I think almost all the equations we've solved have had the variable on the left side. That doesn't matter. Okay, everything we do from here is the exact same from what we've been doing. So subtract 9. So 9x equals 113 and 112. Then divide both sides by 9. And so I get the x equals 112 divided by 9. 12.44. So it's either 112 divided by 9, or if you want to give me the decimal, call it 12.44. That's okay too. Okay, let's do one last one here together, and then I'm going to have you do 9 and 10, and then we can skip the last two. All right. For number 8, again, we need to get rid of the division, and we want to get rid of it on both places. So maybe I start, and it doesn't matter which division I'm getting rid of first. I can multiply both sides by 2 first, or multiply both sides by 6 first. Okay, the order and the division we get rid of first doesn't matter. So I'm going to pick multiplying by 6. So the dividing by 6 goes away, and I have 4. And then as soon as we see like this 3x minus 8 is all on top of that fraction, I'm going to put parentheses around it. And the reason that's important is because now when I do my multiplication, this 6, just like on 7, needs to distribute. So this 6 will distribute. I get 24 absolute values of x minus 48, and then all over 2 still. Then I'm going to multiply both sides by 2. That gets rid of the dividing by 2. Makes the left side 8, and it equals 24 absolute value of x minus 48. Oh, good call. So that's 18. Thank you, Beckett. 18 absolute values of x. That's why we show our work, because it's an easy fix now. 3 times 6 is 18, not 24. All right, so now it's just like what we've been working on, where I can add 48. Add 48. So 56 equals 18 absolute values of x. I can divide both sides by 18. I don't think that divides in nicely, but maybe. 56 divided by 18, it does not. Okay, so your answer, you can either leave it as a fraction, 56/18, or you can give it to me as a decimal. So right now the absolute value equals 56/18, which makes x equal to plus or minus the 56/18, or if you want to give it to me as a decimal, plus or minus 3.11. You can't really see that there. Okay, so decimal answer, fraction answer. Again, I'm not going to be picky about one over the other. Okay, I need everybody to try number 9 and 10. Please do not just sit there and wait for me to show you how to do it. We need to see where we're able to get to, what mistakes we're making. So right now, take about 3 to 4 minutes and just try 9 and 10. They don't. Okay, so the first thing I did here, number 9, is I want to get rid of the dividing by 3. So I multiply both sides by 3. So that gets rid of this dividing by 3, making the left side just 9. And then multiplying this fraction by 3, that makes the numerator 30. And the denominator is just getting multiplied by 1, so it remains unchanged. Then I want to get rid of dividing by 5x squared plus 12. So I'm going to multiply both sides by 5x squared plus 12. Again, that gets rid of this division. So this right side is just 30. And then the left side, 5x squared plus 12 times 9 is 45x squared plus 108. Okay, that happens from me distributing that 9. From there, it's just like all the equations we've been working with. So subtract the 108. I get negative 78. Then divide both sides by 45. And that leaves us trying to square root a negative, which is not possible. Okay, and again, your calculator will yell at you, right? It'll say domain error. Okay, so that is a no solution equation. All right, number 10. This time I started by getting rid of the dividing by 11, so multiplying both sides by 11. That makes the right side 22 absolute value of x minus 121. Again, that needs to distribute there. Then I want to get rid of the dividing by 4 by multiplying both sides by 4. So that makes the left side 40, and now it equals that 22 absolute value of x minus 121. Can add 121 to both sides. That's how I got 161 here. Equals 22 absolute value of x. Dividing both sides by 22 has us add the absolute value of x equals 7.32. And thus, x needs to be plus or minus 7.32.